Hello, we're on 4.04 geometry notes today, and we're going to be doing more proofs. We're going to be talking specifically about isosceles triangle proofs today. So an isosceles triangle, hopefully you remember, is just a triangle that has two congruent sides. What's also true about an isosceles triangle is that it has two congruent base angles. So the angles across from those congruent sides are also going to be congruent to each other. So we have two different ways of using this information in a proof. We have a theorem that can save you a step, or you can write it out a little longer. And each year, usually I have a couple students that prefer to write it out each time. And then, of course, we have some that the majority use the theorem because it makes it a little bit faster. So those are your givens. I want to prove, and of course, I'll give you a picture in just a minute. So I want to prove two triangles congruent, and then I want to prove that angle PSR is congruent to angle QTR, just for fun and review from last class as well. So here's your picture. We've got vertex R up here, P, Q, and then another line here that meets that side of the triangle at T, and right here at S. And we'll set up our statements and reasons. Start with our givens. And then we're going to mark our picture. That looks like I crossed it off. Segment PR congruent to segment QR. All right. So looking at my picture now, I'll change colors here. I want segment PS, I know is congruent to segment QT, and segment PR is congruent to segment QR. I want to prove these two triangles congruent, so I'm going to trace them. So PRS, and let's do a black one, QRT. So I want to get the black and the red triangle to be congruent. Well, how do I do that? Well, if we look at our picture, then we'd say that we have a pair of sides in each, PR, that gives us the sides. We have PS and segment TQ also gives us a pair of sides. So we need one more piece of information. So what else can we take from our givens? They don't share any sides, so we can't use reflexive. We don't have any vertical angles. So let's look back at our givens again. So segment PR congruent to segment RQ. If those two segments are congruent, then what kind of triangle is triangle PRQ? And hopefully you're saying that means it's an isosceles triangle. So we can say then, if that is an isosceles triangle, then we'll be able to get angle P congruent to angle Q, because we know the base angles in an isosceles triangle are congruent. Okay, so this is option one. I'm going to show you two different ways to do this proof. So option one is to first say now that triangle PRQ is an isosceles triangle. And you can abbreviate ISOS, ISOS. And the reason is an isosceles triangle is a triangle with two congruent sides. So by definition, an isosceles triangle has two congruent sides. Once you know it's an isosceles triangle, then, I can use one letter to name angle P and Q because there's no other angles at those vertices. And I can say now that base angles of an isosceles triangle are congruent. So now I have angle P congruent to angle Q. So that gives me an angle, pair of angles congruent a pair of sides congruent, a pair of sides congruent, and is the angle included between these two sides? Yes, it is, which means I'm using side, angle, side, and I have all three pieces of information. So now I can say that triangle PRS is congruent to triangle QRT by side, angle, side. And then the last step we added on to review, we could say angle PSR is congruent to angle QTR. And let's just point out where that is on our picture. PSR is right here, congruent to angle QTR. Well, those two are corresponding angles in these two congruent triangles, which means they're congruent by CPCTC. All right, so now let's talk about option 2. So very similar proof. We're still going to start with our givens. And instead, though, I'm just not going to write them out because we just wrote them. Instead of saying that it's an isosceles triangle first and then getting your base angles congruent, we can skip that step and go straight to saying angle P is congruent to angle Q if you use this theorem. So this is a theorem where before we were using a definition right here of an isosceles triangle. So now we're going to use a theorem that says in a triangle, and it's very, very important you write those 3 words or with the symbol, in a triangle, because it does not work if it's not in a single triangle, in the same triangle. So in a triangle, angles opposite congruent sides are congruent. Or if you want to write it as an if-then, you could say in a triangle, if 2 sides are congruent, then the angles opposite them are congruent. So in a triangle, if 2 sides are congruent, and it can go either way, the angles opposite them are congruent. You could also say if the 2 angles are congruent, then the sides opposite them are congruent. Or in this version up here, in a triangle, sides opposite congruent angles are congruent, and both would work there. And now that you have that, that gives you your side, angle, side. So it just eliminates that one step of saying that it's an isosceles triangle. It still has to be an isosceles triangle in order to use this theorem. And that's something really important to remember. So when you're thinking about using this theorem, I want you to ask yourself, is it an isosceles triangle? And if it is, then you can use it. If it's not an isosceles triangle, do not use this theorem right here. So this is a new theorem. You want to make sure you memorize and learn that theorem as well. It does come up a lot and it's often very helpful. All right, let's go to another proof. We'll do a couple practice ones, a couple a little more challenging ones now that we've been doing proofs for a little while. I think we can start to get into some more challenging ones. So first, here's our givens. You got 3 pairs of segments congruent. I want to prove another pair of segments, so segment DG congruent to segment DH, and here's our picture. So we've got one big triangle here, and then we have another triangle there, and let's just label A, G, D, this point is H, B, F, C, and E. And then we'll do our statements and our reasons, write out our givens, and then of course mark your picture and see where we're at. Work backwards, work forwards until we know what to do. All right, so we've got segment AE is over here, congruent to segment BF, segment AC congruent to segment BC, and segment AG congruent to segment BH, And we want to prove, let's make it yellow, DG and DH are congruent. Okay, so let's start by trying to work backwards for a little bit here. So if I want to get these two yellow segments congruent, they're not part of two different triangles. They're actually only part of one single triangle. So then we'd say, okay, well, what kind of triangle would that be? It looks like if I can get these two sides congruent, that would be an isosceles triangle. So how do I get the sides of an isosceles triangle congruent? Well, if I know that my base angles right here are congruent, let's call those, actually, let's put numbers in there, 1 and 2, and let's call these 3 and 4. So if I could get 1 and 2 to be congruent, then I could use my new theorem and say in a triangle, sides opposite congruent angles are congruent. Or I could say it's isosceles because the base angles are congruent, and then an isosceles triangle has two congruent sides. Let's work back another step. So my goal now is to get 1 and 2 congruent. How do I get 1 and 2 congruent? All right, well, not a whole lot going on here, but I do see some vertical angles. So what if I get my vertical angles congruent, 1 and 3, and I can get 2 and 4 congruent? Okay, but I need 1 and 2 to be congruent to each other. I don't have 3 and 4 congruent yet. So how could I get 3 and 4 to be congruent? And that's when I maybe say, okay, now I see that 3 and 4 are a part of two different triangles right here, these green triangles. So if I can get these green triangles congruent, I can get 3 and 4 congruent, which means I can get 1 congruent to 3, 2 congruent to 4, and then 1 congruent to 2. So there's a lot going on here that we need to think about. Again, try working backwards. Try to pause the video now and just see if you can make that make sense to you and make that figure out your plan of attack. And if you're feeling comfortable, go ahead and try writing it out, and then you can check back with me. The more you can do these independently, the more confident you're going to feel. All right, so I'm trying to figure out now how to get triangle AGE. And when I write this, I'm trying to match up my corresponding parts. So AGE goes from 3 marks to no marks. So I want to go from B to H to F. So if I can get those two triangles congruent, then I can get my angles congruent here. So how do I do that now? So I don't actually know 3 and 4 are congruent. I shouldn't have probably marked that so early on. Or actually maybe what I'll do is I'll mark this with 2 so we don't think that they're congruent quite yet. So now I want to get the green triangles congruent. I have a side, two pairs of sides in each green triangle. But then I have this other piece right here, this given that I haven't concluded from. So how would that help me? So you might be thinking, first you might be thinking segment subtraction maybe. And segment subtraction would work to get this segment EC or EC equal to FC, but that doesn't really help us in the green triangles. So then you might look at a bigger picture here and say, oh, wait a minute. This is all part of this large triangle ABC. If those two sides are congruent, that makes it isosceles, which means I can use my new theorem to get my base angles to be congruent. And I need actually 3 here because I already used 1 and 2 marks on these angles. So I can get those 2 angles congruent since I have the sides congruent. All right, and that brings us to writing it out. So now we're gonna work forwards. So I say if I know that segment AC is congruent to segment BC, I can say that angle A is congruent to angle B. And I'm going to use my new theorem. Very, very important to write in a triangle first because it only works if it's in one single triangle that is isosceles. In a triangle, and this time you want to write angles opposite congruent sides are congruent. If you wanted to write it as an if-then, if that makes more sense to you, you could say in a triangle, if two angles are congruent, then the sides opposite them are also congruent. So now I have angle A congruent to angle B, which means I can say that triangle AGE is congruent to triangle BHF. So I have AE and BF was a side. I have an angle right here, and then segment AG and segment BH is a side. That angle is included between those two sides, so it would be side, angle, side. And I have all three pieces there listed as congruent statements. Okay, so now I want to try to work to get those angles. So I can say angle 3 is congruent to angle 4 by CPCTC. And now I want to bridge it to getting 1 and 2 congruent. So I'm going to use my vertical angles. So I can say angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And the reason is vertical angles are congruent. So now I've got 1 and 2 in my proof, but I want to get 1 and 2 congruent to each other. So now we could use our substitution to say, well, everywhere I see a 3, I can replace it with a 1. And everywhere I see a 4, I can replace it with a 2. So that leaves me with angle 1 congruent to angle 2 by substitution. And then once I have those two angles congruent, that means I have an isosceles triangle, which means I can say that segment DG is congruent to segment DH, because in a triangle, again, three important words, sides, so it's the opposite of what we wrote up in step 2, sides opposite congruent angles are congruent. Again, if it makes more sense to you, write it as an if then. If two sides are congruent, then the angles across from them, if two angles are congruent, you want to start with what you already know. If two angles are congruent, then the sides across from them would also be congruent. Okay, so just a little longer thought process on that one. All right. And next up, we're going to do angle 1 is congruent to angle 2. Segment AB is congruent to segment CD. And I want to prove that EA equals ED. And here's your picture. Similar picture to before. A, B. I'm also going to give you a couple numbers here, so I'll talk about them in the same way. So here's 1, 2. Let's also do 3 and 4. And if I hadn't given you numbers, you of course could write those in yourself as well. All right, what I'd like you guys to do now is, again, it's really important that you can do these on your own. So go ahead and pause the video and see how far you can get reasoning through it. Use your boxes as you need to, and try to conclude as much as you can from your givens. Again, it's okay if you have extra steps that are not true, or that are, as long as your extra steps are true, that's fine. You wouldn't lose points for them. All right, so we've got angle 1 congruent to angle 2 and segment AB congruent to segment CD. We want to get EA equal to ED. So hopefully you thought about working backwards here and said, how could I possibly get those two sides congruent? And there's two different ways that I would think of. One is maybe I'm looking at it's an isosceles triangle. So if I could get these two base angles to be congruent, then I could get the two sides congruent in that big triangle only. Or I could look and say, are these a part of two different triangles? And they are. There's a couple different triangles you could try to use here, which is why I like this proof, because there's multiple ways of doing it. You could look at you might be looking at these overlapping triangles here. Or you might be looking at these triangles here. So sometimes you might try something and maybe you can get part of the way there, but then it doesn't work. So then you have to try something else. So you want to try getting these two small triangles to be congruent. And then we could say that if we know a couple things here. So first of all, you've got this triangle right in the middle. Now this triangle is an isosceles triangle because I know it has base angles congruent, which means the sides across from it are also congruent. So I can get those two sides to be congruent. All right, so that gives me a side, two pairs of sides in each of those pink triangles. I still need something else. So I've used this 1 and 2, but I haven't done anything with the angles yet. So if I look here and I say, well, angle 1 and angle 3, those form a straight line together. So they would add to 180 or be supplementary. I know 2 and 4 also form a straight line together. Together, they would add to 180 degrees, and they would be supplementary. And then I know 1 and 2 are the same. So let's say 1 and 2 are each 30 degrees. If that's 30, then 3 would be 150. If 2 is also 30, then 4 would be 150. So what would be true about 3 and 4? Well, they'd be the same. And that is one of your theorems. And again, you can use your boxes to do that as well, which would allow me to get angle 3 congruent to angle 4. So my goal here is to get triangle ABE congruent to triangle DCE. We always get triangles congruent, and then they have congruent parts, and then we can switch them to equality at the end to get our proof statement. All right, so let's start with getting our segment EB. And again, you could do different orders here as well. Congruent to segment EC in a triangle, very important words. Sides, opposite congruent angles are congruent. Okay, once I get those two congruent, then I can say angle 1 is supplementary to angle 3. In that same step, I can say angle 2 is supplementary to angle 4. Why? Because angles that form a line, or as we call them, linear pairs, are supplementary. Well, now that I have two pairs of supplementary angles, two angles supplementary to congruent angles, because I know 1 and 2 are congruent, I can go straight to saying that angle 3 is congruent to angle 4 if I know my theorem. If I didn't know my theorem, I'd have to set them equal to 180, set them equal to each other, and then use additive inverse, which is how we got the proof of that theorem. So now I can say angles supplementary to congruent angles are congruent. And again, you can write that as an if-then, use your boxes. Now that I have angle 3 congruent to angle 4, so we're going to use side angle side here. So I've got an angle in a pair of congruent angles in my triangles. I have a pair of congruent sides and another pair of sides right here. So, and the angle is included between those two sides. So now I can say that triangle ABE is congruent to triangle DCE by side angle side. But that's not what I'm trying to prove here. I'm trying to prove that segment EA is congruent to segment ED, but those were a part of those two triangles. So now I can say segment EA is congruent to segment ED by CPCTC. Corresponding parts of congruent triangles are congruent. And one last step, and that's just to get it to look just like my proof statement. So I'm just going to switch it to equality by def of congruency. All right, and let's look at one more challenging proof on number 4 here. So given that we are given triangle ABC, we're given segment AB is congruent to segment BC. We have segment ED is parallel to segment AC. I like this proof because it brings in a lot of different things. Segment DG is perp to segment AB. Segment EF is perp to segment BC. And then they give you these here. There's nothing you can conclude from this, but they're just saying that these are straight lines. So sometimes it's hard to tell in your proof if you have straight lines or not. So are they supplementary? Do they move a little bit? So that's just clarifying that for you. And we want to prove that segment GE is congruent to segment FD. So let's take a look at your picture. So you've got here E, D, A, C, B, and then that's F. That goes to that same point right there. And that's G. All right. So I would like you guys to, normally in class, I would have students try to work through this together. So please try to do that on your own, and then I will go through it on here as well. But first, really give that a try on your own. All right, so you've got segment AB congruent to segment BC. We've got ED right here parallel to segment AC. DG is perpendicular to AB. And what's really great about this proof is that there is so much you can conclude. So you could get a lot of points, even if you didn't know how to do this proof, you could still get a lot of points just by concluding from your given. So make sure you conclude from every given you possibly can. So the first one, segment AB is congruent to segment BC. What can I conclude from that? So I'm just going to start off doing it this way. You also may have looked at these two segments you want to get congruent and said, oh, are they part of two different triangles? And then said, well, yes, they are. They're part of this triangle here, and they're part of this triangle here. Again, sometimes it's helpful to redraw those triangles outside of the figure if you want to see them a little more clearly. This is F, D, E, and you can draw E. I don't know why I drew that with an obtuse angle there. E, G, D. So we know we have right angles here. And we also know that they share a side right here. And that's really all we have at this point. So now I'm going to work forward and just conclude from my given. So I've got segment AB congruent to segment BC. Well, that means that this big triangle is isosceles, which means angle A is congruent to angle C. I'm just going to write out the statements, and I want you guys to make sure you have the reasons filled in as well. So your reason there would be in a triangle, if two sides are congruent, then the angles opposite them are congruent. Or in a triangle, angles opposite congruent sides are congruent. Okay, now, so that gives me a conclusion from that. Now I've got these parallel lines. What can I conclude from the parallel lines? Well, here they are, trace them. Where's my transversal? Where there's two lines that cut through. So here's one of them, I can extend it. Now looking at that, and this is the hardest part of this proof, I think, is looking for what can you conclude from those parallel lines. Well, if you look here, you've got between your yellow lines, follow the transversal and the parallel line, you've got corresponding angles. You cannot call angle GED any number because there's an angle inside of it. You cannot call it E either. You have to name that angle with 3 letters. So I can say angle GED is congruent to angle A. And the reason would be if two lines are parallel, then corresponding angles are congruent. In that same step, on my other transversal over here, I can see that I have that same setup. So I've got these two angles are also congruent. So I can say angle, again, you have to name this one with 3 letters. There is no other way around it. If you don't, you would lose points. So angle FDE is congruent to angle C. Same reason, if 2 lines are parallel, then corresponding angles are congruent. Well, if I do that, then I've got this red angle is a part of the green triangle, and this bluish angle is a part of the blue triangle. So those would be like here and here. And again, even though there's only one angle right here, that's because I redrew it, you'd still have to name that with 3 letters. So that gives me an angle, and then I see a right angle here that I haven't concluded in my proof yet, but then that gives me 3 pieces to possibly get those triangles congruent. So before I can do that, though, I need angle GED congruent to angle FDE. Well, just like we did in that other proof, you could take everywhere you see angle A and put angle GED. It's G. Everywhere I see an angle C, I could replace it with FDE. And the reason would just be substitution. All right, so now that gives me a pair of angles in my 2 triangles. I still would need my reflexive property for another side. So it looks like I'm going to do angle, angle, side. So that now I finally have an angle, and I don't have anything else yet. So we'll get the side from reflexive property, and then we still have not concluded from these 2 givens. So I concluded from my parallel lines, I concluded from my 2 congruent segments. Now I can say that, and this one I could put numbers in. So let's call this angle 1 and this one angle 2. And I'm choosing those. Obviously, all 4 angles are going to be right angles, but I only need angle 1 and angle 2. So angle 1 and angle 2 are right angles, and this is straight from your boxes. Very important theorem to remember. Perpendicular lines form right angles. Once I have 2 right angles, now I can say angle 1 is congruent to angle 2. Again, if you're struggling, go to your boxes, find where you find 2 right angles, see what you can conclude. All right angles are congruent. And if you hadn't known what to conclude from your perp lines, go to your boxes, find where you see something like this. Okay, so now that gives me another pair of angles there. And now I've concluded from those 2 givens. And these 2 givens, there's nothing you can conclude. They're just straight lines, and that one's just telling us it's a triangle. All right, so now I have 2 pairs of angles. I still need my pair of sides, so I can say segment ED is congruent to itself. And the reason for that would be your reflexive property. And that gives me my other side. So now I can say that triangle GED, it's getting a little crazy with my writing here, sorry. Triangle GED is congruent to triangle FDE, and that would be by angle, angle, side. Almost done. Now I can say that segment GE is congruent to segment FD by corresponding parts of congruent triangles are congruent CPCTC. All right, hopefully that makes sense. If not, go back over it, listen to it again, try just pausing it and rewrite that proof out again. Draw it out, draw another picture if you need to so you can label it differently and more clearly. If you started to get, like mine is starting to get a lot of lines on it, try drawing your triangles outside of the figure, try working forwards, try working backwards. All great things to try on these proofs. If you have any questions at all, please make sure you let me know. And I hope to see you soon. Pie out.